Good afternoon, everybody. So I'm going to go over the solutions here or kind of show you guys how we set up some of these problems that we started last Wednesday and then we worked on them Thursday and Friday. Let me go ahead and I don't think you need to see my face. I'm going to shut this off. Plus, I'm going to flip my screen so you won't see me anyway. The problems that we set up, the first set of problems were on end behavior. So let me give you a little bit of a background before we actually get into the set of problems. Remember we talked about end behavior as being what's going to happen on the left and what's going to happen on the right side of a graph. So when I say the left and right side, I mean like what's going on. We've got the x-axis, then we've got the y-axis. So when I say left, I mean what's going on. This is 0. Sorry about that. 0. So what's going on to the left of 0, which is towards the negative infinity side. And then we say on the right side is what's going on to the right of 0 towards the infinite side. So let's say this is the right side and this is the left side. I don't know why that keeps happening. I'm sorry, guys. Okay. When we're talking about the end behavior, we're going to use two parts of the polynomial to figure out what's going on. So we're going to take a look at the power or the exponent, and then we're going to take a look at the coefficient, the leading coefficient or the biggest coefficient. The coefficient of the term with the biggest exponent. So let me give you guys a little reminder up here as to the 4 different cases you can have. So first we're going to look at the power. Okay, the power is either going to be an even power or an odd power, meaning like 2, 4, 6, 8 or 2, 4, 6, 8, 3, 5, 7, 9, so forth. And then underneath that, within the power, you're either going to have a positive coefficient or a negative coefficient. Positive coefficient or negative coefficient. Okay. So first we're going to look at the power, and then we're going to look at the coefficient. If it's positive, both the left and the right sides of the graph will be pointing up. If it's an even power with a negative coefficient, both the left and the right are going to be pointing down. Now on the other side, if you have an odd power with a positive coefficient, you're going to have the left pointing down and the right side pointing up. And if the coefficient is negative, then the left side is going to be pointing up and the right side is going to be pointing down. So let me see. So the top, first we look at the power and then we look at the coefficient. Okay, so let me see if I can squeeze this in here. So for the first one we have, what do we have? Odd power. So let me write it this way. I think my thing's running out of battery here. So our power equals 5, and that's odd. And then my coefficient equals 3, and it's positive. So we've got an odd power and positive coefficient. So that means that my end behavior is going to be such that the left will be going down and the right side will be going up. Okay, pretty easy once you see the pattern. But we can't just draw the arrows. We have to write it in a special way. And the way we write the left side is we always have to write it in this special way. As x approaches negative infinity, the function will approach negative infinity. So what we're saying is that this is from the left side. What makes it the left is that we're using negative infinity. Okay? So as we change our x values and go more and more negative or going more and more to the left of the graph, the value of the of the function is going to also be negative because the graph is going to be pointing down. And then to describe the right side of the graph, we use this phrase: as x approaches infinity, then f of x approaches, and what do we say? The arrow's pointing up, so that's in our infinity positive. Okay. So let me kind of show you, like, draw a graph so we can see what that looks like. This is what I'm talking about. Let's say I've got a graph. This is my x, this is my y. And let's say I've got a function that looks like this. Oops, not that way. Let's undo that. What is going on here? Okay. Let's say the function looks like this in blue. So what we're saying is that on the left side, because this arrow is pointing down, it's going farther and farther to the negative infinity. And up here, because it's pointing up, we're going farther and farther into positive infinity. Okay. So remember, on the graph, up is positive infinity, down is negative infinity. To the left is negative infinity, and to the right is positive infinity. Okay. That's where we're getting these directions from. So at the end of the day, all of these problems are going to include the same initial phrasing, or the same start, which is as x, the arrow means approaches, as x approaches negative infinity, f of x approaches what? And this little part, that's the blank, that's the part we're filling in. That's what we're looking for. As x approaches infinity, so to the right side, f of x approaches what? We're going to fill in the blank. And in order to fill in those blanks, we got to look at that coefficient, and then we've got to look at that power. So the power is 3, which is even or odd? That's going to be odd. And then our coefficient, which is -6, is a negative number. So let's go back to our little cheat sheet here, and we say when we've got an odd power with an even negative coefficient, we're going to have this case where the left is going up and the right is going down, which means the left is going towards infinity. Let me see if I can write this a little bit of a different way. The left goes up, the right goes down, going towards positive infinity, and this is going towards negative infinity. So our answers here, on the left side, we're going up, positive, and on the right side, we're going down, negative. Okay. You guys should start to recognize a pattern. So that means, like I said, for every problem, no matter what, we're going to have the same phrasing. As x approaches negative infinity, f of x is going to approach some number or some direction, and that's what we need to fill in. The right side is positive infinity, f of x, some number. Okay, so all these numbers 1 through 6 are going to have the same initial setup. All of this thing that I just wrote here, that's what you're looking for, and you're going to fill in the blank based on the coefficient and the power of the leading term. Our power is 6, which is even, and then we've got a positive coefficient, which is positive. So that means both the left and the right are going to be pointing up towards infinity. Okay, I hope you guys can recognize the pattern, and you're going to do exactly the same thing for all of these problems. They're all going to start the same way. As x approaches negative infinity, f of x approaches something, and you need to fill in the blank. Okay, So I think you get the idea. Please finish the rest using the power and the leading coefficient to figure out the end behavior. Okay, let's take a look at the next ones. Describe both the power and coefficient of the leading terms. So we're kind of doing the same thing here, except we're going in the opposite direction. Instead of looking at the equation and trying to figure out the exponent and the leading coefficient, we're looking at the graph and we're going to back out what the power is based on the direction. So look, all we have to do is inspect the graph and see that the left is going down and so is the right. So I've got this scenario, both pointing down. If I go back up here and look at my little cheat sheet up here, I can see that very clearly. In order to have the case where both are pointing down, I need a negative coefficient and I need an even power. Okay? So let's go back down here. So in order to have that case, I need to have, what do I need? Even power, negative coefficient. Okay. Describe both the power and coefficient. So we don't know what it is. We don't know if it's going to be a 2 or 4 or 6 or 8. But we know that we're going to have at least an even power and a negative coefficient. This one, we've got a case where we've got one pointing down and one pointing up. Okay, so we've got left down and right up. We got to figure out which power gives us that combination of one up, one down, and which coefficient gives us that scenario. Okay, same for this one. Left and right. So left, we've got pointing up, and right side, we've got pointing up. So this one's easy. When they're both pointing in the same direction, I know I'm going to have an even power. And as far as the coefficient goes, I know that if it's a positive coefficient and even power, then both my arrows are going to be pointing up. If the coefficient is negative, both the arrows are going to be pointing down. So you guys make sure you do number 8. So number 10 is a little bit more complicated. We need to classify each function, then graph the function. So actually, before we classify it, what we need to do is, we're going to classify it first, and then we're going to graph it, and then we're going to identify the key characteristics. Okay. So I don't want you guys graphing these by hand. I want you to use Desmos.com and graph it in there, and then bring your graph over to this sheet. So let me show you how to do that. The first thing is to understand the classification is like to talk about, we're talking about the degree. That's all we mean. Okay, and the degree is the biggest number exponent that you have in the polynomial. So in this case, the biggest exponent or the biggest power is 3. See? There's nothing bigger than x to the power 3 here. So our degree is 3. And those we call a cubic. Okay, if you can't remember what words we use, that's fine. I just need you to at least write degree 3, degree 4, degree 2, or whatever. The domain we'll get when we graph it, the domain and the range. The relative min, the max, we'll get it from graphing. This we'll get from graphing, this from graphing. End behavior we can actually get without graphing because we have our little tricks. We know that all we need to do is look at the power, and then we need to look at the coefficient. Let me erase this. We need to look at the power and the coefficient for this one. This one's easy. We just did them. What's our power? Well, we see it right here. Our biggest power is 3, and that's 3 is an odd number. And then what about the coefficient? What's the leading coefficient here? What's in front of that x to the power 3? Well, we never write it, but we know that we've got an invisible 1 there. we know that we've got this invisible one always hanging out in front of these variables. So our coefficient is a positive 1, so it's positive. And what does that give us? Odd power, we know that one's going to be left and one's going to be up and one's going to be down. But which way? So we have to figure out the coefficient is positive to know that our behavior is going to be like this: left down, right up. And remember, we have this fancy way of writing it. We write as x approaches negative infinity, which is the left side, the function approaches what? We're going down on the left side, so we're going to put negative infinity. And then for the right, we're going to say as x approaches positive infinity, the function's doing what? It's going up towards infinity. So we're going to say approaches infinity. Okay, so we didn't need to graph it for that. Here's what I want you to do. Go to Desmos.com. Take this equation, x to the power of 3 plus 9x squared plus 24x plus 21. Graph it into Desmos.com. Let me show you where. Desmos.com. Select graphing calculator. Type it in here. X to the power of 3 plus 9x squared plus 24x plus 21. That's my graph. So I just need to transfer this over to the worksheet. The easiest way for me is to create the table. So look, you got to pick this little gear here that says edit list. Click on that. Pick this little icon that looks like a table. Convert to table, and it's going to give you all the freaking points here that you need to use to graph this into your worksheet. So you got all the points you could ever need. Okay, it's going to give you the basics. So it's going to give you 0, -2, -1, 1, and 2. But you can see, like at 0, 21, that's not going to fit on your worksheet. Neither is 55, neither is 113. So we need to pick numbers that are on this side of the number line. So let's pick 2. Let's keep 1. 0 is not going to help us, but let's try -2. And then I'm going to click here and I'm going to change. Oh, we already have 2. Let's try -3. Let's change that 1 to a -4. And then let's change that to -6. So see, I can just add whatever numbers I want. I can use these to get me the next. I've got 1, 2, 3. I think that's enough points. So let me see. I've got -2, 1, -3, 3, -4, 5. So I'm just getting that from right here. Okay. Then I'm going to come over here and I'm going to look for -2, 1, -2, 1, -2, 1, -3, 3, -1, 2, 3, 3. Then I'm going to do -4, 5. -1, 2, 3, 4. 1, 2, 3, 4, 5. What's another term I need? Let's do -2, 1. Okay, so let's try this one here. That one's almost like -5, 0. Go to -1, 2, 3, 4, 5, 0. And so now I have some points there that I can use to create my graph, and I know it's going to look something like this. So when I graphed it, look, it matches up with my end behavior, so I know I did that right. I've got on the left side, it's going down to negative infinity. On the right side, it's going up to positive infinity. And now I can use this graph to determine my domain, my range, my relative min, max, and so forth. So the domain is, remember, when these arrows up here, I draw the arrows, I know that that number, that graph is going to keep going up and to the right forever. It's going to go all the way, like, you can't draw it. We can't draw it because of the space. But in reality, this line's going to keep going up and up and up and to the right and up and to the right and up and to the right. It doesn't matter which number you pick on the x-axis, you will always intersect with a point on this graph. to the right side, and if you go to the left to the negative numbers, you'll always intersect with a point that's going to intersect with the graph. It's hard to see because we only have a small portion to draw on, but in reality, this is going to keep going down and to the right, down and to the right, down and to the right forever and forever and forever, and keep growing and growing. So since we're going to go all the way to negative numbers and all the way to right numbers on this graph, we're going to see that the domain is all real numbers. And in the range, again, if I'm saying this graph will eventually go and intersect with any number y all the way down to negative infinity, and do the same all the way to positive infinity, that's going to be, the range will be all real numbers. Okay. Let me erase some of these little deals here. So now let's talk about the relative min, the relative max. We're going to look at the points that are on the highest and lowest points of the graph. So this is like the maximum point before it comes back down. And that's at negative 1, 2, 3, 4. Negative 4, comma 5. So our relative our relative max is at negative 4, comma 5. Let's take a look at the minimum. This is the relatively lowest point on the graph. So that's going to be at negative 2, comma 1. Now, when we're talking about increasing and decreasing intervals, that's going to be kind of a weird thing. We're looking at it from, when we're talking about intervals, we're always going to go from left to right on the graph. So let's look at it this way. Let me kind of erase this garbage, make it a little bit more clear. So if we go from left to right and we start going this way, we see the first little segment of the graph right here. As we're going from left to right, so as we're going up the graph, we see that these numbers, as far as the x-axis goes, these numbers we're looking at the y. So look, right here, this is at negative 1, 2, 3, 4. This point is at negative 1. This point is at 2. This point is at 3. And this point is at 5. So as we're moving along the graph in this direction, we see that the y values are getting bigger. So that's an increasing interval. So from negative infinity up until this point right here, comma 5, we have, comma 4, negative 4, the graph is increasing. As we come over this hump and start going down the line this way, we see that our y values are getting smaller, ultimately getting to this point, which is at x equals negative 2. So we have a decreasing interval from negative 4 to negative 2. Okay. And then the last segment here, from here to here, we see that it's increasing. So there's two increasing intervals, from negative infinity to negative 4, and then from negative 1 to positive infinity. Okay. So that's how we need to do all of the rest of the ones that have a graph. So that's number 11, 12, and 13. You're going to graph it in Desmos. You're going to classify it, remember. So let's take a look at number 11. The classify part is easy. You look for the term with the biggest exponent, and that's it. This is a degree 4. The domain you'll have to graph. To find the domain and range, you'll have to graph it. To find the relative mins, you'll have to graph. These you'll have to graph. End behavior, you can use the power and the coefficient to figure out what the end behavior is going to be. Okay. Okay, so I hope that helps get you guys set up at least. If you have additional questions or still need help, please come to tutoring hours. I'll be available Wednesday morning from 8 to 8:40. Let me see, power is odd or even, and then coefficient is positive or negative. I'll be available for tutoring if you still need help. Come on Wednesday from 8 to 8:40, or on Wednesday afternoon 4 to 10, or Thursday 4 to 10. Okay.